I clicked the start recording button.
Okay, we are now recording. So welcome everyone to the May 2025 New York JavaSIG meeting. Thank you all for coming here. Thank you to the people of the future who are watching us. So tonight we have an AI theme, and we have Andy Piper from Diffblue. Diffblue is a new sponsor of the JavaSIG, so thank you for sponsoring us. Thank you for the pizza. Excellent. And thank you to Bank of New York for hosting us here. Thank you, Bank of New York. So before I turn everything over to Andy, if you notice that the second talk, my talk, is about AI embeddings. And this is part of my AI for the Busy Java Developer series. And actually that QR code, if you want to, that LinkedIn course is free for another month. So if you want to have that free course, you could just ignore the LinkedIn marketing for that. So that's going to be free for another month. And as I was mentioning to Barry before, when you're learning AI, like everybody's learning about AI and doing AI, a lot of people are putting AI into production, generative AI into production. So I want everybody in our community to understand how to properly learn this stuff, because there's a lot of confusion about this. It's not another Java framework. It's just not like oh, I'll just use Spring, or just use this framework or that framework. You have to understand machine learning, but you really do. It's not just a simple framework. So I'm going to time myself. I have 20 minutes for my Thunder talk. As we know, lightning talks are 5 minutes. Thunder talks are a little bit slower. So it's 20 minutes. So let's go. What are AI embeddings? So first of all, why do you learn this stuff? Why is this important? So AI embeddings, or embeddings in general, they're used to determine how similar one thing is to another. It's used in a neural network, which is the heart of most machine learning, or what the press calls AI. Machine learning is a neural network. So embeddings are used in a neural network. Now, what are the use cases? Well, there's a lot of use cases for similarity, right? For semantic search, I want to search through all my files for, I don't remember the exact words, but it was something like this, right? Semantic search. Or I'm looking for if the customer sentiment is similar for a certain product or service. Or for doing translation, like instead of translating word for word, let's find out what the semantics of the sentence or the paragraph was. Then we do the translation. So there's a lot of use cases just in text. And certainly for images, if you want to find similar images, or doing style detection, there's image similarity. And of course, if you have things like Spotify, it's like, well, you like this song, you might like this song, right? So that's similarity, those type of similarity. How is that done? How is that done? Let's talk about text embeddings, because image embeddings and audio embeddings are very, very similar. So let's talk about text embeddings, since we all know about strings. So text embeddings, what is a text embedding? So an embedding, a text embedding is a one-dimensional vector. So we know what a vector is, right? We're Java developers. One-dimensional array, right? It's a one-dimensional array, and it turns out of single precision floating point numbers. That's all it is. So when someone says this is embedding, don't think it's like, oh, my head's going to explode. That's all it is, okay? And it's called an embedding vector. And here's what one looks like. Now, you're probably never going to see another one again, but this is what one looks like in the wild. It's a one-dimensional array of single precision floating point numbers. It's not hard, right? But you're not going to, normally when you're putting things in production, you don't look at these numbers, okay? And most Java developers get a little concerned when they see numbers. I'm going to have to know about math to do this, or it's like it's too complicated. But these things are really useful, because they are used to calculate how similar two things. And if that's, I asked ChatGPT to take that image here and make everybody similar, which it seems to have done a good job. But wait a minute. So what is similarity? Okay. So let's look at an example. Let's say I have a simple two-dimensional plot here, and I'm plotting how nutritious some foods are based upon their cost, just like 2 dimensions. So I have like sunflower seeds are very costly, and they have hardly any nutrition value, which I actually didn't know before. And we have something like kale over here is very nutritious and is very, very inexpensive. But say my question is, I have strawberries and spinach and carrots. How similar are carrots and spinach to strawberries based upon those two dimensions, right? So what does similarity mean? Well, one way of calculating similarity or distance, how far away something is. If something is closer, it's more similar, right? So here I have strawberries, carrots, and spinach, and I have the coordinates. So I did the calculation. So it's just a square root of the sum of the x2 minus x1, y2 minus 1. You learned this in high school, right? So it turns out that carrots are closer. Carrots are more similar to strawberries than spinach. So that's 2 dimensions. Now let's look at something a little bit 3 dimensions. So let's say I have a bunch of colors and someone says like, I need color green. So let's look at the green here and I find out which ones are more similar to the first one. So of the 5 here, is 3 more similar to 1, or is it 4 more similar? What would you say? Why would you say that? So that's qualitative. That's qualitative answer. Well, you have to be, instead of qualitative, you're right. Let's go a little further. Let's use a coordinate system. What's a good coordinate system for colors? RGB, right? I mean, there are other ones. I put some of them down here at the bottom. There's CYM, there's HSV. There's a whole bunch of coordinate systems, but one we all know and love is RGB, right? So I have the coordinates of those colors, right? And in 3D space, since it's 3 dimensions, I have those 3 colors. And let's look at the distance from 1 to 4 and 1 to 3. And again, here's that calculation, right? In this Euclidean geometry, right? It's the square root of the sum of the differences of the coordinates. And it turns out that 3 is closer to 1 because it's closer. 88.33 is less than 153. So clearly 3 is closer. So 3 is more similar to 1. So everyone understand that we did 2 dimensions, we did 3 dimensions. Now what about text? Okay, now instead of 2 or 3 dimensions, text has many dimensions, right? It's like, are there adverbs in this? Are there pronouns? Is there capitalization? So there's many, many dimensions. So depending upon who you talk to, someone says, well, there's 384 dimensions. You know, if you talk to OpenAI, they said there's 1,536 dimensions. If you talk to another company, say, well, no, there's 2,048. So there's multiple dimensions because different neural networks are different sizes. So the embedding vectors are different, right? And the word embedding comes from mathematics. You're mapping from from food to nutrition and cost, color into red, green, blue, and text strings into many characteristics. Everybody with me so far? Okay. And here's how easy it is to get an embedding vector. So here I'm using OpenAI. So this is using LangChain4j, and I'll show this running a little bit later. That I use the embedding model class, and I'm going to use the text embedding. This is a language model or embedding model that I'm going to use. And on the string is 1 fish, 2 fish, red fish, blue fish. I asked the OpenAI server for it, and there's the embedding vector. So this is the second time, and probably the last time you'll see what the internals of one. It's not important what the numbers are per se. It's just that this represents that string. That's what's important, right? Very loosely, each element is a characteristic of the string. It's very, very, very loosely. So now I am embedding vectors. How do I calculate if one string is similar to another one? I can't show you a graph because we're humans. We can't see past 3 dimensions unless you're an alien from another universe, right? So, but there are ways of calculating distance in n dimensions. And we saw that in Euclidean way was like the square root of the sum of the differences. So this applies to n dimensions. So I can use this calculation. And if it's close to 0, that means they're very similar. If it's far away from 0, it's not. And there's a whole bunch of different calculations for this one was Euclidean similarity. This paper or there's a blog post there's 17 of them. It's a really cool site that teaches a little bit more. in depth about data science if you're interested. But there's 17 different ways, and the one that, since we're talking about Euclidean, that's the way you do it with Euclidean geometry, using the square root of the differences. But there's one of those 17 is called cosine similarity. Now this one is interesting because what do we know in our machine that can handle matrices really well? GPUs, right? So cosine, when I learned this, when you learn about matrix manipulation, when I learned about it, my teacher, you learn about dot products. It's like, take this, you multiply that, put that over this column, you learn that. I would ask my teacher, why? Why are we learning this? And I never got a good answer. If my teacher would have said that if you could put the characteristics of a song in that matrix, you can find out how similar that song is to that song, or how similar that company is to that company, or how similar that car is to that car, my head would have exploded. So are you kidding me? This is the reason why we're learning how to do this. So cosine similarity is a way using matrix manipulation to calculate similarity. And because it uses matrices, it's great for GPUs. So this calculation is a popular one of the 17 here. It's very, very popular. And it's if you're a math person, it's basically, we're talking about if two vectors are pointing, if they're similar, the angle is small, that means they're very similar. If they're apart, they're not that similar, right? That's about the depth of my data science. So if I said, like, we have this, and I asked you, okay, now you're a Java developer, implement that, what would you do? If I asked you, like, implement that. Well, if I said I wanted to see code. This is 2025. What would you do now?
AI.
Yes, you would ask an LLM. Sure enough, I asked ChatGPT, and it gave me some nice code. Now, of course, you have to test it. You have to have a critical mind when you look at the code, because it's 1/3 of the time it's hallucinating, right? So I tested this, and it looked pretty good. And so I have this little program here, and the first string, I like Java, and the Java programming language is enjoyable. The similarity is 0.8. That's pretty cool. Here's two completely different ones. I like the Java programming language. Tonight is pizza night at the baseball stadium, or pizza night at the JavaSIG meeting here. And the similarity is only 0.13. So those two strings are not similar. So that code, I mean, literally, that's that code right there. It's like one page of code. Okay, but at the bottom here, while you can do this, since there's 17 different ones, don't. Someone else has already done this before you. So there are embedding vector database companies that they supply you with these calculations. So while you can do it yourself, don't. Someone that knows a lot more about data science than you do has done this, so just use their service. Okay. Now, again, where do I use this again? Let's say you're building a chatbot, and probably the next time I talk about AI, we'll talk about RAG systems. But when you build a chatbot, you have to look at, let's say you're building a chatbot for your enterprise docs. So the chatbot has to know about your docs, right? So it has to, like, look at what the user wants, and then look for things that are similar in this database. So you have a database of your docs, right? And you have those embedding vectors. You take what the user wants, you look up maybe something about Java records, or something about Java, and then you look for, so give me the top 10 that are most similar. You take those, and you take the user's prompt, put those together, and you give that to the LLM. That's the only thing that the LLM understands. It's just what's in that so-called context window. So that context, and if you're learning about AI, that word context is one of those critical words. When you learn about generative AI, that word is one of the big words. Understand what context is. So that's how to show code. Okay. Okay, so this one is good. Can you see that? It's kind of small. How's that? Okay. So here's that code I was showing. There's a one fish, two fish, one fish, two fish, red fish, blue fish. Okay. What happened? Okay. Yay! Yay. So again, these numbers. I mean, actually, it's you really don't look at these numbers. It's just that this represents that string. So where's my other one? I'm just at time too. Huh? Okay, so I like the Java programming language. Actually, let's put something else in here. Somebody give me a string. I don't like the what? Okay. U-A-G, period. Go on, okay. Was that?
We can't see you typing it. Okay.
Oh.
Just to let you know.
0.84. Okay, now since it has Java in there, let's put something else in here. What's another one? Okay, give me a string.
Colorless green ideas sleep furiously.
What?
It's
Color?
Chomsky's.
Color? What's it?
Colorless green ideas sleep furiously.
Wow. .08. Okay. All right, and then my time is at an end. Any question, real quick? Yeah, shoot.
Why embedding models are so special from non-embedding models, like other models?
You mean a regular language model?
Yeah, why embedding models are so different? Why can't you use language model to embed?
Well, language models don't generate.
They cannot do matrix calculation. They cannot do the math like a cosine similarity.
Well, it doesn't do the cosine. So I'm using that outside. I'm getting the embedding vector from like this an example, OpenAI, but they're not doing the similarity for me. I'm doing that in my code. Yeah.
You get this code?
Sure. Yeah. It's in one of my repos. I'll send you. Just send me an email. I'll send you the link. Any other quick questions? Is this clear about embedding vectors? This is like one of the key things you have to learn when you're doing generative AI. Yes.
The embedding vector, like when I first saw it, I was imagining it's just like kind of a mapping between characters or words to just some, I did like integer, but you're like because you have to talk to an LLM, it's a lot more complicated than that. Is
right.
Kind of the way I'm understanding it.
The word embedding means I'm going from a string into a numeric representation of that string.
Requires an LLM. You can't just like write something that's really
simple. I mean it's actually it's like the second to the last layer of a neural network. Yeah.
How different are images and audio files than all this? You said they're similar. Can you use the cosine?
So that's a good question. What do I do for images and what do I do for audio? So the embedding vector, the embedding service I'm using here is for text. If you want to compare 2 bits of Java code, you wouldn't use text embedding, you would use a code embedding, right? If you're using a video, you would use video embedding. If you're using sound, you would use a sound embedding. Embedding is for certain types. So don't mix. And if you say like, I'm using an LLM and I'm going to ask you for code and I'll code it, but it's not a code LLM, you're using the wrong LLM, right? There's 1.5 million LLMs out there.
Show me what the LLM is in there, the one that you use.
So the one that I use is, oops, sorry. So I'm using OpenAI and this particular model. OpenAI has 72 models. Yeah, that's that particular. I just happened to pick that one. There's like, I think I have 4 or 5 of them. They have the cheap, fast one, or the free, slow one, and then you have to pay more for the other ones. No, I just wrote this code. Yeah. But the similarity code since I'm not a math person, I asked ChatGPT for the code. Actually, you know, Claude is really good for code generation. Anthropic's Claude, that's really good for code generation. Yes.
Deterministic, is that right, or is it non-deterministic?
In what sense?
Like you'll get the same result for the same string every
Yes,
time.
that's
Oh,
right.
okay.
Exactly right.
All right.
And, you know, one thing before we tried this before. Oops, that's too small. I'm going to type in the same string. Is music my typing music? All right. So I think Barry suggested this last time. Okay. So their two strings are the same. So, okay, I get one. Now, if I change Java to a lowercase j, okay. Notice it's slightly different. So it takes into account case. That's an interesting experiment.
Change that?
Put the J capital. So we are changing the.
It changes back?
Yes, correct. We change only the. Because in theory now it should have been dropping.
0.94. Yeah. Anyway, so I think I'm at my my time. Yeah, Vlad, one last question.
Some context where it would make sense to normalize the strings.
To normalize the strings.
Yeah. Let's say uppercase and remove all the punctuation, or so that you wouldn't have these noise.
That's a good question. So if you were doing, you'd have to agree, that, you know, amongst in your team, like everything in the database, the vector database, is going to be lower or upper, and we're not going to differentiate between.
And people do this in real life scenario, or they basically keep.
I haven't heard anybody do that.
Yeah.
Anyway, thank you. I went 3 minutes over. Sorry. So now we have Andy Piper from Diffblue. Talk about AI and testing.
Thanks, man.
Sure.
All right. This is where it all pulls out.
No.
Do you have water, Andy?
Yeah, I did get one there. So we did. It would help if I had my glasses on.
Do you need power?
I think I can survive for the time without power. It doesn't take that type of adapter anyway, so.
Plugged in both.
I am plugged in both. Yeah.
There you go.
There you go. You're on there. No.
Looks good to me.
Mirror.
Yeah.
Mirror is okay there.
Everything's good.
Okay. Good. All right. Good. All right. Thanks, everybody. So I'm Andy Piper. I run engineering at Diffblue. We're a small AI startup based out of Oxford, England. We span out from the university there. So our two founders were ex-academics. And I'm here to talk to you about reducing developer toil. Autonomous AI for enterprise testing at scale. Bit of a mouthful, but I'll sort of unpack it a little bit. So this is sort of rough flow, and we'll be finished before 8 for sure. So first, a little bit of a digression about software engineering. Is it getting easier? Is it getting harder? Then how does AI help with the process of writing software? Does it help? Then about testing, which is what we do, but how AI has an influence on testing. What does good testing look like? What does useful testing look like? And then how can AI be applied, particularly in the agentic sense, to testing in Java in particular, which is why we're here at the New York JavaSIG. And then I've got a sort of demo to wrap up with, and obviously questions. A little bit about me. So I did a PhD, Cambridge, England, not Cambridge, Massachusetts, in MapReduce. Long before Google made lots of money doing MapReduce. They didn't give me any of it. Shame, so I'm still working, unfortunately. But yeah, that was my background. I then worked at BEA. Everybody heard of BEA? So yeah, so I was I led the core server team for WebLogic Server based in San Francisco. So I lived and worked in San Francisco for a number of years, working on networking, high availability. RMI IOP was my speciality, if anyone remembers that. But you know, Corba and Orbs, and a long time ago. BA was acquired by Oracle, and I went as part of that acquisition and was managing their real-time data streaming products. They had a real-time data streaming product called WebLogic Event Server. I then got really fed up with big company politics, not getting anything done. Hopefully no one works for a big company here. So I became CTO of a small startup doing real-time data streaming based in the UK. Was called Push Technology, now called Diffusion Data. I then got a bit fed up of living hand to mouth, not knowing whether you get paid month by month. So I worked for CBRE, biggest real estate company in the world, which really convinced me that I did not like working for a big company and all the red tape involved. So I'm back at a much smaller company, Diffblue. We're about 45 people, and I run engineering there. So I don't write much, if any, Java code these days, but I've written a lot in my past. Okay, so engineering. Let's talk about engineering. Is software engineering getting easier? Who thinks it's getting easier?
Compared to what?
So compared to 5 years ago, 10 years ago, is software engineering getting easier?
Depending which generation of
Okay, you can only answer yes or no.
So
So hands up if you think it's getting easier. A few hands? Hands up if you think it's getting harder. A few hands. Anyone sitting on the fence? Can't? Yeah, okay. So I've done this talk before. That's about representative. There's about half of the room think it's easier, half of the room think it's harder. So let's look at this in the sort of wider context of development. So why might you say it's getting harder or not harder? Well, the big thing is that people are expecting more. So, and more of the same people. So anyone here in an environment where headcount is rapidly increasing and you've got more developers than you know what to do with? No, that's I mean, unless you work for OpenAI, maybe that's true. I don't know. They're hiring like crazy, but generally, same set of resources trying to do more, or fewer resources, which is us, right? Trying to achieve the same sort of thing. So this is a common. This resonates with people, presumably. Yeah. Okay. Is it true for enterprise? In enterprises, I would say so. Yeah.
Okay.
Yeah. Okay.
That's why I like.
Why I didn't like big companies? Well, I ran large teams. I always needed more people. I always couldn't get them. They were always too expensive. I mean, it's the same, you know. I mean, we haven't even touched on, even if you had the money, can you find enough good people to do what you need to do? I mean, that's also a challenge. So, okay. So in that context, there are some other things going on. So security becoming a bigger and bigger pain in my ass, I might say, or you know, it's like everybody wants security now. We have to sell we sell to large organizations such as this one. Security is like right up there in terms of things that have to be addressed to even get across the, get through the door. And everybody expects it, like, that cyber checks and balances, there's just, everybody's doing it now. It's not going away. So it's a given and it's increasing. And also the validation we do of stuff is increasing. So in particular, things like DORA, people heard of the DORA metrics? So, okay, so I can't remember what it's like, DevOps research, something or other. Basically, so if you read the book, everybody read the book Accelerate? You come across the book Accelerate? I highly recommend it. So you have. You work for Diffblue there, and you're not in engineering, so how come? So basically, DORA is a set of 4 metrics that is that have been found to be good proxies for engineering velocity. So like if you can score highly on these 4 metrics, then generally you have a high performing team. And it's things like time to deploy, cost to deploy, cost to rework, those sorts of things. Definitely worth looking up. But they did a bunch of research, surveyed many organizations, and sort of measured their ability to deliver high quality software against these metrics, and they found these 4 were very good proxies for doing a good job. And the great thing is we have tools that can measure those sorts of things, and people use those tools. I mean, there's simple things like SonarQube and all those sort of stuff. People are just measuring stuff more and more to check that the output that they want is sufficient. But underlying all of this is cost, right? So cost drives a lot of these things, particularly the resource thing. But how you manage that cost is getting a bit more tricky as well. Like, do you offshore everything? Maybe, maybe not. I have a good friend. He ran engineering for a Silicon Valley startup. Their main development outfit was in Kiev, which wasn't great for them, a few years later. So I think that this whole kind of the ways that people manage these costs is changing, and people are beginning to sort of bring things back in, but still everybody expects it for the same cost. So that's the sort of wider development context. What about developers? Okay, so this is maybe a bit contentious. And in fact, I had someone in the room last time say, well, actually IQ is increasing about 2% every decade or something like that. But my contention is that generally we're about as smart as the generation before us, at least from computer science. It's not like we've all turned into superhuman developers. Maybe AI has helped us with that, but generally we're about as intelligent as our fathers were. We're taught differently, sometimes for the better, sometimes for the worst. I mean, I do a lot of interviews. I get a lot of people claiming many things that are not backed up by their actual skills, and so it doesn't feel to me like we're sort of on a rapid increasing trajectory in terms of developer quality. But we do know what good looks like, because there's always these pockets of people who are doing amazing jobs. And so DORA is one. We sort of looked at that research looked at a lot of different organizations, but we know what the bar for good looks like, and the challenge is to sort of get everybody there if you can. One of the ways we do that is we use tools. So we know what good looks like, so we use tools to enforce that good. And everybody here, I'm sure, uses things like Sonar, like PyTest, tools for security testing. There's just an endless array of tools that can be used to measure good, to measure best practice. So this talk is about toil. So where does the toil come from? Well, we're expecting more, but the checks and balances are increasing. And so my contention is that developer toil is around those sort of checks and balances, the red tape, if you will. And addressing that often isn't fun. Addressing security concerns, it can be just a long, laborious task, I mean, maybe people here like that sort of thing. I don't know, but I think most developers want to focus on the creative side of, you know, creating great software that has good outcomes. And a lot of these things are just seen as costs, as toil. And typically, the only reason we can raise these bars is because there is tooling that might help with that. Like if we're having to address all these things manually, it would just get way too complicated. I mean, for instance, we use AI specifically to address security questionnaires. Like it's just become overwhelming, you know, trying to answer those sorts of things customer by customer, whereas AI can do the sort of pattern matching and plug things in. It's the only way we can manage output given limited resources. All right, so that's kind of the scene setting, the context setting. How does AI play into this? So, is AI helping with development? Hands up if you think AI is helping with development. Quite a few hands up. Hands up if you think it's not helping with development. Okay, I guess this is okay. This is a sort of AI themed talk, so maybe I would expect that. Hands up if you think it's about a wash, like neither helping nor. Okay, so we've got a few people sitting on the fence, and I think it's true. It is helping, but it also has the potential not to help. So I'm gonna sit on the fence here as well. So when we use AI, I think the one thing we know, we've all experienced this. If you use ChatGPT, you can increase your raw output quite dramatically based on very limited prompts. You know, I got ChatGPT to write us a business continuity plan with, I don't know, 10-word prompt, and it gave me a 10-page output. It's very easy to generate very believable raw output. I mean, obviously that's text, but you can do the same, similar things in code. Generating raw output is not a problem with AI, not the problem at all. But is it good? Is it quality? Is it trustworthy? And oftentimes it's not, right? So I've used Copilot. Who here uses Copilot, for instance? Okay, so who here who uses Copilot gets 100% result every time? No, I mean, no, it's not true. Now, what it gives you can be useful, but generally you have to check it, right? That's the point. You're using it to increase your productivity, but you have to still be as part of that process because you know it could easily be wrong. And often the output from these LLMs in particular are below the quality bar that we've just talked about. We know what good looks like, but AI potentially gives us output that's below that bar. And by the way, reworking code is a cost. If you look at DORA metrics, for instance, code rework is one of the big costs. If you have to put code in production, it's got bugs, you have to rework it, that is a red flag in terms of developer productivity. And similarly for Copilot, okay, you've got to check these things. You're producing output, but if actually what you produced has bugs and gets to production, you're going to have to rework it. It's a cost. Even in the development flow, checking these things takes time. It's a cost, and these costs have to be borne in mind when you're determining whether it's a net benefit or not. So one of the things you have to do is verify, right? Test. I work for a testing company, right? You can see where this is going. But it's important to note that verification is essential, right? We've got to, like, who here would write Copilot code and just not check it? Anyone do that? No. I mean, you wouldn't, right? But it's better if you don't have to verify at all, right? It's better if you don't have to go through that process of checking stuff. Make it, there's this Japanese engineering. They're all about mudder and or I don't know how you pronounce it, but right first time, right? Right first time engineering. It's the same for software. If you can get things right first time, you don't have that cost involved of going around the loop, and generally you get better outcomes at higher velocity. And the thing you have to remember is that GenAI LLMs are not great at right first time. A lot of these LLM-based products have heaps of stuff wrapped around the core model just to provide checks and balances and catch the mistakes that the LLM is clearly going to make at some point. Okay, so what about testing? So I talked about verification. Testing is verification. It's software verification, right? So we all want to do that. We all want to verify software. But who's going to verify the verification, right? Who's going to test the tester? Are you going to get an LLM to do that? Maybe, maybe not. So LLMs, AI for software works best at the moment with humans in the loop, because you need that sense of verification. You need to verify the output, because making mistakes is quite costly. If you get AI to do the verification, there are challenges. I mean, hallucination is just sort of one of the sort of examples of problems with AI in this space. But anyone here use Copilot to verify Copilot? Seems unlikely to me. But live dangerously maybe. So my thesis is that testing needs to be trusted to be useful, right? If you're having to constantly verify the verification, again, is a cost that's just going to slow you down. So what does useful testing look like? So here's what I would say. Okay, it's got to be correct, right? You've got to be testing the right thing. It's got to give correct outcomes. Got to have high coverage. You can have very correct tests, but if you're not covering much of your code, it's not that useful. I've got to catch bugs. So, this is a classic one. You can have high coverage tests that catch no bugs if you have no assertions. Sort of something that's not immediately apparent to everybody, but you've got to have coverage plus assertions in order to catch bugs. Otherwise, you're not really testing anything at all. It also needs to be understandable. So although testing is something people would like not to be, generally developers like to do less of, it's still a fact of life, but it still needs to be managed by developers. They've got to understand what the testing does. It needs to be so that you can change it when the software changes it. And corollary with that, it needs to be maintainable as well. So you need to be able to change tests in a way that can evolve with your software, and also runs fast and cheaply. So I've come across organizations where getting stuff into production takes months just because of the testing overhead, and that cycle time can just slow things down to an absolute halt. And then finally, kind of needs to understand what your code does. So it's no good testing the comments. You've got to actually test the code. You can see where that's going. All right. So what does useful AI testing look like? So that's useful testing without AI in the loop. What does useful AI testing look like? Well, must generate useful tests, I would contend, all the things we've just looked at. But also, I think, and we think, without intervention or human verification, because as soon as you start to introduce a human into the loop, you kind of lost some of the value of AI. If you can't generate tests without getting involved, your scalability is gone at that point. Now, we can sort of argue about whether that's true or not, but that's certainly the position we take. But if you have the two together, then you can reduce developer toil, because suddenly you, the developer, is not having to be involved in some of this make work that is making your life harder and slower. So the good news is it can be done, but my thesis would be that interactive code assistants are not necessarily the answer to this particular problem. They're a good answer to lots of other problems, but not necessarily the testing problem. And one of the reasons is that they take focus away and time away from not the problem, take away focus from the problem that needs to be solved, which is actually writing good code to implement a solution. And it's an opportunity cost for productive work, especially at scale. So that's kind of the AI context. let's look at agentic AI in particular, so not code assistants, and let's sort of compare and contrast. So agentic AI solutions are typically, well, autonomous, goal-directed, self-improving. There's a whole pyramid of agentic kind of ishness that you can look at if you're interested. But I think the key thing is that they're autonomous. So human is not in the loop with these solutions. They are, acting with their own agency, hence the name agentic. Now, what does this look like in comparison with LLMs? And although I'm probably sounding like I'm dissing LLMs to a certain extent, it's worth recognizing these are all just tools, right? They all have value in particular context, and you just need to know when to apply the tool to get the value that you're looking for. So AI assistants, for instance, produce an 80% solution, but actually when you're writing code, maybe that's okay. If the algorithm that Frank asked ChatGPT for, I don't know whether it was bug-free, but it was useful to you for, to get where you wanted to go. It saved you time with you in the loop to check it. And so, this sort of 80, and they're getting better and better, but there's that gap between 100% trustworthy and what they're currently able to generate. Whereas AI agents should be 100%. Like, you should be able to guarantee the results to basically fire and forget to some degree. So agents are autonomously performing tasks that are trusted to be correct. Now, and this is sort of re-emphasizing the point. So assistants are useful in that creative code writing process. And in a sense, it doesn't matter if they have errors, as long as they can be reviewed. But sometimes you need to not underestimate the cost of that review. I've used ChatGPT and Copilot to write some algorithms, and there've been very, very subtle bugs in the algorithms, which has taken me a long time to fix, a long time to find. And sometimes, the juice is not worth the squeeze. You kind of think, well, actually, if I'd written this myself, at least I would understand what's going on, and probably I would have saved longer time or more time overall. But of course, you never know that setting out. You never know sort of how close to the perfect solution you're going to be given. So agents useful in other places where they need to be error-free, and I would argue that testing is one of those areas that needs to be error-free. So how do you get to error-free? LLMs, not so great, because there's this lack of precision and trust. They're very good at much more fuzzy tasks, where you're sort of trying to get stuff that's like other stuff, hence the text-based nearness stuff. They do that really, really, really well. But where you want precision and trust, not so great. There are other ways of doing some of these things, and we in particular use reinforcement learning. Our finding is that reinforcement learning can actually be more productive for these sorts of things, given the way that it works. And I'll sort of give a brief overview of how our tool works, just to sort of give you some background. So yeah, a little bit of the pitch here. So we have an agentic AI solution. So this is reinforcement learning driven test generation for Java, which operates autonomously and gives you a 100% solution. So we will give you Java tests that are correct. We won't give you Java tests that aren't correct, that don't run, that don't compile, that don't pass. And I think the other thing that's worth mentioning here is, as soon as you get into the autonomous space, where you can do things without a human, you can then scale at that point. So one of the problems with assistants is that with a human in the loop, your scaling is inhibited by the number of humans that you've got in the loop. Whereas with an agentic AI solution, where it's fire and forget, you can basically write tests, for instance, in our case, for entire code bases overnight without a human. But you can never do that with a human. And we've also run kind of studies where we looked at using Copilot to generate tests versus using us to generate tests. Although sometimes the actual time spent was similar, the thing that's easy to miss is that with Copilot, because you've got this back and forth, you've got focus time just constantly being taken away from you in terms of actually writing the code. Whereas if you've got something that you can trust, fire and forget, okay, maybe it takes, I don't know, a few minutes to write the code, because you're not having to keep switching context, you're actually getting a lot more done in the meantime. Okay, so here's kind of how we work, because I get this question all the time, and yeah, this is as much as I can tell you without getting into IP, so apologies, I might not be able to answer all the questions. So, people familiar with fuzzing, test fuzzing? Who's come across test fuzzing? Yeah, a few. Okay, so essentially test fuzzing is you fire random inputs at your code and see what breaks. That's essentially it. You take your program, you generate random inputs, you execute the code, and you see whether there are issues or no issues. And it's a great way of finding bugs quite quickly without writing exhaustive test corpuses. And I've used it many times in previous lives. The challenge with it is it's very unthinking. So you're just kind of iterating through, doing random permutations of inputs. And also, it's very hard to start to build up, you know, it's great if your methods take strings, for instance, very easy to permutate through different strings. But if your method takes some kind of object that contains another object, you know, which has some context, fuzzing doesn't really work very well in those sorts of things where you have to build context. So that's fuzzing, which is all about execution. So you can use that to then write tests. You can do fuzz test generation. So instead of just seeing what breaks, what you can do is you can observe the behavior change and then write a test to enforce that behavior change. So it's you know, subtle difference from fuzzing, but this is actually test generation using fuzzing. Now, not necessarily very useful if you're fuzzing through, I don't know, 1 million permutations, you get 1 million tests out at the end. That's not very useful to anyone, but it is possible, just not very useful. So the next step that you need to do is you need to, you know, condense the test that you're writing to be based only on changes. So you're observing behavior changes, you're only going to write tests for behavior changes that are different. And so you can go around in a loop, you can generate a much smaller set of tests, still based on essentially random inputs, and start to generate testing or tests that enforce the behavior of your current program. All well and good, but it still doesn't necessarily get you to tests that are that useful. So what else can you do? Well, turns out there's quite a lot you can do, and we do a lot of this as well. So the first thing you can do is you can stop using random inputs. You can start taking hints from other things to figure out what kind of data might exercise the code under test. Things like stuff you'd find in the bytecode. So we work on bytecode primarily. For instance, we'll look for strings in the bytecode and we'll use those as inputs in test generation because they might be useful. They might not be useful, but they might be useful. But it gives us these sort of hints about things that you could try to generate tests. And then there's things like domain knowledge. So, you know, for instance, we know what a Spring test should look like. So if we see Spring code, we'll try to write a test using Spring-like inputs. And there's just a lot of those sorts of heuristic where you can guide the search for inputs that generate useful results without having to kind of trawl the logical union of all Java code, which is obviously pretty much infinite. Now, the other thing that you want to do is you don't want to just write tests based on what's changed. You want to write tests based on a goal. And this is kind of where the reinforcement learning piece comes in. So with reinforcement learning, you generally have a goal, you know, a reward function that says whether you're getting closer or further away from your desired outcome. And in our case, that's primarily coverage. So we're looking for tests that have both high coverage and unique coverage, but there are other metrics that you can use. And we go around in a loop, basically, looking at tests, evaluating the effectiveness based on this reward goal, and then constructing new inputs based on that loop. And then finally, because this is reinforcement learning, and basically we're doing a sort of probabilistic search of the space. We can't possibly write tests for all of the possible inputs. What we're doing is we're keeping a tree essentially of things that we're going to try with the current code under test, and we continually expand or cull that tree based on things that we find in the code, based on things that we see during execution to guide the search. And this is kind of what reinforcement learning is. It's a probabilistic search of the solution space, because you can't just brute force these sorts of solutions. You're trying to find, in a limited time with limited compute resources, you're trying to find solutions relatively quickly and accurately. It's much too large, so you're going to search probabilistically. And that means that you can spend time looking in the most likely places. For instance, I gave a simple example early on. Strings that you find in the bytecode, for instance, gives you a sort of indication of where interesting change might happen. And yeah.
So when you use this, so you're looking at code, you're watching it when it's running.
Yeah.
Right, and then you kind of go into this feedback loop, right? The generative test, and then you have a human that's using this thing as a tool and then correcting it.
No, human's not correcting it at all.
Oh, okay.
No, so it's completely autonomous. So that guided by the reward function. So basically, it's just going around this loop really, really quickly, trying to build up extensive coverage of the code under test, based on the tests that have currently been generated.
Follow up on that, how do you actually achieve correctness of a test? How do you know which test is correct?
Yeah, so good question. So we can't measure intent. So we can't tell what the developer intended to do. We can only tell what the code actually does. And so the tests test the code as it is currently written. Now, obviously, for some people, that's maybe not exactly what they want, but for the vast majority, that is exactly what they want, particularly with things like legacy code bases where there's not many tests. The running code is
Another question?
Well, hang on. Let me. So once you've got good test corpus for running code, it means that then you can safely change that code and catch regressions. Now, if the code was wrong in the first place, no one's going to be able to tell you that, and an LLM is not going to be able to tell you that either.
So you said that you catch the change in the code, but how do you know if the change is correct? Let's say that original code was made correct, so you have the baseline for the test. Then the code has changed. The autonomous agent would learn. Would it accept the change as the correct, or would it accept the change as, okay, there is something, and please check on that?
It's a good question. So you would, in that particular case, you would do what any developer would do, and you would look at the code, and you would look at the tests, and you'd figure out whether the code was wrong or the test was wrong. And if the code was wrong, you'd fix it. And if the test was wrong, in our case, you just regenerate the test. But at some point, someone has to make a decision in that scenario. The machine can't make that decision for you.
So this the loop is largely to provide the coverage. Is that fair?
It's to provide coverage, but it's also we're exploring the space here. So, for instance, a typical example is you can provide lots of permutated inputs and get null pointer exception out there at the end of it. That's classic kind of sort of Java outcome. So the loop is trying to find inputs that are useful, that actually generate something, generate observable behavior changes that then we can write tests off the back of.
When there are no more changes, no more tests, when it's
When
getting
you run
to
out
a
of time.
steady point.
When you run out of time, because literally it's time bound. So we could go on forever searching and searching and searching, but no one wants to wait that long. So it's trying to find that happy medium where you get a reasonable amount of coverage and without kind of boiling the ocean, as it were. I think I have to check, but I think we might do 1,000 iterations, something like that, which runs in a reasonable time and gives, you know, a reasonable amount of coverage.
Timing is.
It would be a few seconds per test, but obviously if you're writing hundreds of thousands of tests, then it's going to take longer. So, but it's something that can be parallelized as well. Okay, so I'm getting to the demo here as well, which then will answer some of your questions. You can ask more questions around the demo as well. So yeah, our product is called Cover, goal-oriented, fully autonomous AI agent. And it automatically writes tests for Java by searching for them. I think, and it's faster than a human. I'm gonna switch to the demo now, and then come back to my slides because there's a bit more, but I think the demo is better at this point. Okay, black screen. That's not good, is it? Maybe I have to get out of slideshow mode. No. All right. Let me just try unplugging and then. There we go. Okay. So for some reason, that's very weird. It's never happened to me before.
You're getting that even when there you go.
Yeah. Strange. Okay, so the tool, so there's a CLI version of the tool which you can run across entire repositories, but there's also an IntelliJ plugin which is useful for demos because it gives the sort of more interactive. You want the larger font. Gosh, remind me how I do that. Control plus. No.
Command Shift plus.
Command Shift plus. Command plus. Drag. I don't think I'm going to be able to make it bigger. Sorry. Squint. Yeah, sorry. Unless there's view. Better? Okay. All right. So so this is the IntelliJ plugin, and this is Spring Pet Clinic. Anybody familiar with Spring Pet Clinic? It's kind of the Spring demo application, which we find quite useful for demos. And a couple of things I wanted to point out. So this is the Spring code owner controller. So this is a controller class using Spring Web MVC. And a few things to note about this is, you know, so I've sort of outlined the kind of, in simplistic terms, how we work, but it's worth understanding some of the nuances as well. So one of the things about controller classes is they're all annotation driven. So you can't just write, this is not regular Java code in the sense of the word. You kind of need to understand what the annotations mean in order to write sensible tests, in order to set up the appropriate context for it. And also, of course, these are HTTP type methods, so you've got to understand about that. And what I'm going to do is write a test for process find form here. So a couple of things to notice about this is there's 4 code paths here. There's the kind of NPE code path, I guess. And then there's one where there's no owners, one with one owner, and then the sort of default code path. And you can see there's various strings in the code, And what I'm going to do is kick off the process of test writing for this method. And you can see it's sort of chugging away in the background. But obviously what we want is we want complete coverage, which covers all of the branches in this code, essentially for the minimum number of tests. And that's what Diffblue cover is able to do. I probably should have kicked this off before I started talking about Spring Pet Clinic, because no one likes waiting for stuff. But it shouldn't take too long, unless I have the network problem like Frank did. Okay, so there we go. We've got 4 tests. Now, because we know that people like the sort of dopamine hit of looking at stuff in IDEs, we have the kind of review option. So you can review new tests versus current tests you've got. What I'm going to do is I'm just going to accept all of these and trust the machine. And the first thing I'm going to do, okay, so now we can see I've got my extra owner controller Diffblue tests here. And the first thing I'm going to do is I'm going to run all of the tests for this package, just to check that it does what it says on the tin, which it means that it generates tests that pass, compile, and run, which it does. And runs quickly as well. This is the value of unit tests, right? They run quickly, so you can check things out quickly. Okay, so let's have a look at the test that it actually gave us. So I think the first thing to notice is that the context is understood. So this is writing Spring native tests using the appropriate context configuration for owner controller, using the normal annotations, injecting appropriate beans, and then let's sort of look at a test here. So we've got this first test it's given us is has 2 owners in the list, and so that was our kind of default code path, the happy path that most developers are aware of and testing for. And it's attempted to give us a test name that tells us roughly what's going on, because that's important to developers, important to be maintainable in that way. And also we've tagged it to say this is a Diffblue test, just in case you don't like Diffblue tests and you want to delete them all or know what's what from the other things. The next thing to notice is that although all of these owner fields essentially take strings, we're providing strings that make sense given the context. So addresses that look like addresses, city that looks like city, etc. US telephone numbers, I think it does that even in the UK, unfortunately, but yeah. But it's strings that make sense, because these sort of things matter to developers. If you just put foobar in here, developers would be like, well, that's not a test I would write, so it's not a good test. So the next thing to notice is that we're doing appropriate mocking. And so this is something that people, when they're writing unit tests, struggle with. It's actually quite a, who likes writing mocks? No. So generally people don't do it because it's hard, or they make a hash of it. And one of the nice things about using a tool for this sort of thing is it can mock the surrounding objects that are required to run the test, but it can do so in a very standard, very comprehensible way that doesn't require you to be asking ChatGPT or Stack Overflow the whole time, how do I write a mock for X? So we've got the mocks there, and then it's setting up the mock and executing the mock. And again, using the correct sort of strings that it's discovered from the bytecode in the code under test. And then what we'll see is we've got the other code paths. We've got the single owner test code path being tested here. And then we've got the no owner, the empty owner code path testing here. And then we've got this extra one, and I haven't quite figured out what the difference is between this test and this other test. Probably something for me to examine on the plane, maybe. And obviously took a few seconds. This can be done at scale for pretty much any Java code. So any questions about the demo before I switch back to my slides? Yep.
I don't know if you set up for this, but I would imagine you must have done it because you mentioned it before. If you run PyTest on the generated test, what would I expect? Because
You'd expect
It's about 80 to 90% from PyTest in terms of test strength. So generally the tests we write are very high strength tests. If you get a test, like that's just
one trick with, and I believe you mentioned it earlier with mocks, is that you could write 100% test coverage with mocks that test absolutely nothing. And
so we definitely
don't do that. So we have several customers who use PyTest as their benchmark for test quality, and we always score very highly in those things. So I mean, we haven't put much effort into sort of maximizing that. It's just that as long as you're got high coverage, good assertions for all of the code paths, generally you score quite well in those sorts of tests.
You use the phrase if it generates a test, does that mean sometimes it gives up?
Yes. So you can imagine methods where the setup is so complex. Like, so for instance, we had a customer who wanted to help them write tests for their code. Their existing tests required 1,000 lines of Java code to set up for the test. And it's going to be hard for a machine to kind of guess that from first principles. So in those sorts of situations, you might not get a test. We are currently working on a feature which basically allows us to seed the test generation process from existing tests so that we can sort of bypass some of that.
Follow-up question. When that happens, does it alert you to that fact, or do you run the coverage tool and find out that like that area you need to do yourself?
Did it alert you to the fact that it couldn't generate a test? Yes, it definitely does. And there are certain situations where it's obvious why it couldn't generate a test. For instance, private methods, something like that. So we actually have some integration with Open Rewrite, where it will refactor your code to make code more testable. For instance, like changing private to protected, or sorry, private to package. Now you may not want that, so it's not the default, but there is some support there. I think a more useful aspect of where we'll use Open Rewrite is we'll also fix, for instance, Maven POM issues where you haven't got the right dependencies for running Greco or JUnit or whatever. We can do that automatically relatively easily. There was another question.
There were 4 tests that you had to review. Why would they say that?
Why would you say?
It said that 4 of the tests you had to be reviewed. So
You mean why would we? Okay, so
I know you accepted, but
it's an option. So you can click a button where basically it'll just write the test and you forget about it. What we found was that we got user feedback where when developers were using this in their workflow, they quite liked to look at the tests as they were going in before committing. And another reason is that in certain circumstances where we can't write a test, we can at least write a template for you, which you could then also review and say, well, okay, this is not a complete test, but it's the starting point for a test. Do you want to accept that or not accept it? But it's something you can turn off or on it. Yeah, it's not tied to it. Oh, I'm not on power. So
There was one more question. Yeah. Oh, no. 2 more questions.
Yes. So I suppose you start with code to introspect and to forward engineer testing. I wanted to ask if you ever thought about starting from, usually when we do projects in software, we have use cases, and then we have scenarios, we have acceptance test. It's in English, right? There's a scenario, and then we go down and create more defined, more on the unit testing side of the integration testing, the unit testing.
Yeah.
However, I was going to ask you if you have thought about starting with English goals, which are scenarios, down to now we're going to start harassing
Yeah, no, I
it's another path.
We have certainly thought about that, and of course there are domain-specific languages that allow you to specify things in particular ways that we have also thought about sort of supporting. We haven't seen a massive amount. We do ask this question from time to time. We haven't seen a massive amount of demand for that, but there's no reason why we couldn't do that.
Follow on that. On your example, when you fill in the address looks real, but how did you have an algorithm to say?
That's a good question. Yeah. So
that is currently a heuristic that's baked into the product. And you can currently, define how some of these seedings work. So you can say, if you've got particular data that's relevant to your business, you can say, when you see this kind of method, this is the kind of data I want to provide. One of the things we're looking at is using LLMs to generate dictionaries for some of this information to provide good guesses for that sort of input.
I thought you already have.
Okay.
I'm just curious about mocking. Are there any limitations to what you can mock? For instance, if you go about MQ connection?
There are limitations in the things like static methods. So, for instance, we only support static mocking via Mockito 4 and later, so we don't support power mock because hopefully power.
Applications will have lots of environmental connections.
So
and
we
can mock. Mocking is not the problem. It's not mocking that's the problem usually. So we can mock pretty much anything at all, but often that will generate too many mocks. And so one of the keys is, when do you not want to mock things? So we allow users to specify the things they want mocked and the things they don't want mocked. But we're also always looking for ways where we can be a bit more intelligent about what we mock and what we don't mock. Frank?
2 minutes. I've got 2 minutes. Oh, yeah. All right.
I was just wondering how deterministic it is. Like, if you
good
generate twice on the same code, you always get the same results.
You do.
Same coverage.
Yes.
So it is deterministic because that's generally what customers want. They don't want tests changing all the time. There are certain scenarios where it's not deterministic, like date-based tests or that sort of thing. But it is deterministic. Let me just finish my slides so that in my 2 minutes, just so you can see. Okay. Because it is important that I mention this. So so this is part of a broader landscape of AI, agentic AI testing, and it's verification of software. But why do you want to verify software? Well, typically people are, software is changing through ongoing development, but also people are doing upgrades to Java versions, to framework versions, they're doing application modernization. And this is something that Modern does quite well through Open Rewrite. And we've actually just announced a link up between Modern and Diffblue to allow people to do upgrades to their Java real estate and then use Diffblue to do the verification before and after. So I just kind of wanted to mention that because if you don't test, then change becomes risky. That's why we test, right? We test so that we can make changes simpler. That's how the Modern thing works. I won't bore you with that. I've done the demo. And this is my final 30 seconds. It's precise, it works at scale, it's continuous, it's cheap, and it's agentic. And I think I said all that. So if you want to try it, those are the QR codes for the plugin and CLI. We've got a GitLab and GitHub integration. And I don't think I have any time for questions, right? Everybody asked them all.
Well, first of all, thank you very much, Andy. Time for one question. One more question. Okay.
Does mocking reduce the code coverage?
Does it reduce?
No, generally mocking is the only way you can get good code coverage because, yeah.
First of all, thank you. Now we know how we can get our tests fast.
No problem.
We have a few announcements, and I all know you're all expecting me to give away IntelliJ licenses, and I am, but I have another announcement first. This summer, we're going to be doing a mentoring program for the Java user group. The mentors will probably all be the leaders of the group, although if there's a ton of demand, we may expand it out some more. We'll be sending out a form via the mailing list. Raise your hand if you're on the mailing list. How does everybody find out about the meeting?
But everybody's on the mailing list.
Well, our mailing list is linked from the homepage. I recommend you sign up for the mailing list. This is for people who live in the tri-state area, so sorry to our guests. But sign up, let us know what you're interested in terms of mentoring so we can consider that when pairing it up. It's a 6-week time commitment. Mentoring will either be in person or online, depending on your and your mentor's preferences, once a week for an hour. So we're excited to start that. Our second news is, of course, who doesn't have an IntelliJ license that wants an IntelliJ license? Okay, we have enough people that we're doing a legit raffle today. Sometimes almost everyone has one, and it's like, congratulations to the one person with their hand up. Okay, so you all know how raffles work around here. You say a number in order if you want a license, and I pick a random number, and then you get a license. We're going to be giving away 2 licenses today.
Yeah, 2.
Okay.
So raise your hand.
Raise your hand again and keep it up.
If you want to join a raffle.
All right. 1, 2. We're doing this in order. 4.
5.
Okay.
There's 9.
Oh, no. Sorry, I didn't see you. And you can see who our regulars were. They knew that we were doing the numbers in order because I always do it that way. First winner is number 7. Who's that?
Yeah,
What's your name? Say again? Eric. And our second winner is number 9. Okay. Email us at info@javasig.com. That's why we had you say your name, so we know who actually won the thing. And we will email you an IntelliJ license good for a year. It's good on any IDEA product. So, PyCharm if you don't do Java or whatever. Finally, a few of us will be going to Shake Shack after for burgers or shakes or beer. If you're like to come, see Barry and me at the end and we'll walk over. Finally, our host has encouraged us to not stay in the room too long today. So by showing your appreciation, please leave. Thank you.